In science, we have, our human physiology, we generally count 5 senses, okay? Generally. So we can see, we can hear, smell, touch, and we can taste. These are your traditional 5 senses, and basically most of anything that goes on in the world comes to our mind, our brain, through those 5 senses. Now, we all probably know people who tell you they have a 6th sense. Okay? So, is anyone here pretty sure they have a 6th sense? You want to raise your hand? A lot of hands come up. And if you say you have a 6th sense, people, if they believe you, then they'll say, hey, that person has a 6th sense. That's an important person. And I'm thinking, I'm not impressed. Not impressed with your 6th sense. You know why? Because in science, we have science senses. Let's see what shows up in the science sense list. Oh, we can detect magnetism, radio parts of the spectrum the eye and the brain can't detect, space-time curvature, microscope. We have countless senses. We are probing the universe so far beyond the capacity of our 5 senses that for you to come up to me and say, I have a 6th sense, I say, fine, I have 30 senses, all right? Get in line, all right? These are the manifestations of the methods and tools of science. Not only do those methods and tools enhance your senses, like a telescope, it allows you to see farther than your eye can see. We have special telescopes that enable you to see bands of light that are not visible to your retina. Microwaves, X-rays, gamma rays, radio waves. None of that is visible to the human eye. But the universe is talking to us in those bands. And we want to know what the universe is saying. That requires clever machines, clever detectors, brought into the service of this inquiry to find out what the universe is actually doing. So we not only enhance our eyesight, we create eyesight that otherwise wouldn't even be there. So I've got some pictures of machines. See if I can, so that looks like some kind of MRI. This is a particle accelerator, a linear accelerator. Over there, what else do we have? A spectroscope, analyzing light. Maybe that's an MRI. Oh, wait, these are machines. Machines you stick your body into in the hospital, right? There's a Geiger counter. Look at, we can detect radioactivity. So the way you detect it is some of your body parts fall off, right? That's just a little late, all right? You want to be able to detect it when it's happening, not after it messes with your DNA. So that's a Geiger counter. What else do we have here? That probably measures like pH or something, and we have no other way to do it. Maybe that's a mass spectrometer. Big old expensive machine. Oh, nice little multimeter. Good one right there. Every home should have a multimeter. Right? You know why? Because you know the battery tester you get? Alright? It tells you good or bad. Wait, but there's how about anything in between? A multimeter, you tell you how bad is it or how good is it? Extra information you can acquire. So what else do we have now? More machines. There's a good infrared scope. And that's an X-ray machine right there, a portable one actually. And another particle accelerator. Barometric pressure. We have no meaningful way to measure that without tools. Good old telescope. And, a seismograph. They've been in the news lately. Maybe we'll get back to that. Any Connecticut residents out there? We'll find out. So what is the scientific method? You've heard a lot about this. I'm going to define it for you. Real simple. Real simple. You ready? Here you go. It is do whatever it takes to not fool yourself into thinking that something is true that is not, or that something is not true that is. That's the scientific method. This is deep, but it's not more complex than this. Do whatever it takes. You don't have a good memory, so you write it down. Your handwriting is bad, so you type it in. You witness something that just happened. The brain-eye combination is highly error-prone. You know these books we have, that optical illusions? Right? Who doesn't love a good optical illusion? I have 5 optical illusion books at home. But those books are misnamed. They should really be called brain failures, because that's exactly what is going on. There's a simple line drawing. Is it in the page? Out of the page? I can't figure it out. Oh my God. Is one line longer than the other? I can't. I don't like the perspective. Simple pictures mess up your head. So the odd thing about this is, in the court of law, eyewitness testimony is counted very high. But in the court of science, it is the lowest form of testimony you could possibly bring to bear on anything. And so you're going to find a way to make sure the error-prone sensory system of your human physiology does not get in the way of finding out what is true. So, what that means is, I'll tell you what it means. The scientific method is a confession. The scientists are human. We carry bias, longings, prejudice, all other shortcomings of judgment that affects everybody else. The difference is we're self-aware, more self-aware, and we invoke forces that help correct that. And that's what distinguishes the enterprise of science. It's a confession. We need extra tools to help that. And then you say, well, what is a truth? So what are these 2 pictures of?
Pumpkin pie and apple pie.
Yeah, pumpkin pie, right, of course. These are all over the internet. Really geeky people on Halloween and other times. In fact, if you look closely on this pumpkin, like the digits of pi are carved into the pumpkin. So the value of pi in base 10 is like a math truth. 3.14159264, and it goes on and on and on and on and on. It's a transcendental number, and you learn about that in mathematics. You can prove the value of this number.